What's up everyone? In this quick video, we are going to look at how to migrate from shared preferences, which is the old deprecated solution to store key value preferences data in your Android app, to something called Datastore, which is a much nicer Jetpack Compose library. Datastore provides a rich set of APIs to store your key value pairs of data consistently and asynchronously throughout your Android application, which is much better than shared preferences. So here I have the JekyllX application, which is an open source Android application to manage your Jekyll powered blogs directly from your mobile device. I began working on this application around 3 to 4 years ago and used shared preferences at first. This settings activity uses this settings class to handle the different options that a user can alter within the application. We pass in the context to the settings class, which is used to initialize this shared preferences object. And we have a generic way to get and set shared preferences values. We have this sealed class setting type, which defines the different kind of values that the application supports settings for. For example, a setting could be an integer value that a user can alter. It could be float, it could be string or boolean. Within the setting type, we have the default initializer data class that holds the value for the actual setting. And based on this setting type class, we define the actual settings which are available in the application. For example, there could be a setting for trimming logs, which is named with the key trim logs, and its default value should be true by default. Just like that, we have different settings which use the setting type class, and within it, the different type of value that this setting store. Within the actual settings class where we pass in the context, we use a generic method to get or set the setting. For example, if the setting we want to get is an integer value, we use the getInt method from the shared preferences object, and just like that, use the specific method and cast it to the generic kind of value that the get call expects. And by default, the setting type uses the default value when there's no alteration in the setting. Just like that, in the set function, we pass in a setting and the value that we want to store for that setting. And we edit the shared preferences, and based on the value, we use the specific shared preferences function to store the value of this setting key. And after we're done, we just apply it. So it's a very basic setup to use generic methods to store different setting types. And now we are going to look at how to use Datastore to basically do the same thing using generic classes. Here I have the Android documentation open, which describes the two different type of Datastore libraries that we can use. One is the preferences Datastore and the other one is the proto Datastore. Android guides has a nice code lab that describes the difference between all of these three different APIs. So as you can see, shared preferences does not have a lot of features compared to preference Datastore and proto Datastore. And between these two, the only difference is that proto Datastore assures type safety with protocol buffers. It is a language by Google, which is used to define the kind of data that is going to pass between different classes, and its serialization is type safe. But we are only going to focus on preference Datastore because setting up proto Datastore requires a lot more setup, and we are going to assure type safety using the generic classes anyways. Let's get right into it. Now, the setup of preference Datastore requires some dependencies to be added to the build.gradle.kts file, which I have already done. Let me just show you. So I have added this implementation for Datastore preferences, which is basically this implementation. Now let us just create a new package for the store that we are going to use. And within this, let's create a new Kotlin class called preference store. Actually, let's just not call it a class for now, and let us see what the official documentation has to say. So working with the preference data store requires us to create an extension object on the context class and delegate it to this preferences data store function, which is provided by the preference data store library that we just imported. So let us just copy this piece of code and paste it over here. It will complain about a certain dependency is missing. So let us just import them. Now the idea is to use this very similar setup to the settings we already have, where we define a generic way to get and set the preference values and have a list of default preferences. So we are going to replicate these classes within the preference store. Let's start by creating a data class for preferences that we are going to have. It is going to be a generic class, very similar to this setting type class. Now each of its initializer will have a key and default value, which GPT is very happily helping us out with. But we don't want to hardcode it as string. we're going to use something from the data store example. So as you can see, we have something called integer preferences and boolean preferences, things like that. So if we try to check the type of int preference key, it returns a preference of key of type int. So what we can infer from that is we can use this preferences.key and pass in the generic that will basically accept any kind of preference from the data store library. So what we are going to do is we are going to type in preferences and not use the generic type from our own package, rather use the one from data store. And yeah, we are going to use the dot key class within and pass in the generic. Now what happens is whenever we try to create a preference from this preference class, its key will be basically one of the type of the classes provided by data store library, such as int preference or boolean preference, things like that. And the type of default value will depend on the type of value that it is allowed to store. So now we have this generic class, which is kind of equivalent to this class. And as you already can see, it's going to be much simpler than this. Now we are going to map this default settings to our new preference class. Let's just copy this. And what we can do is we can have a companion object and just pass in the different settings that we just copied. But we'll have to format each of it to a value because we are trying to create a preference from this data class. So I'll show you one of the examples. As you can see, we had to do minor bit of refactor to make this work. Now we'll basically have to do it for everything else. So now I am done mapping the settings to this new structure. We're basically using the same settings, kind of the same way, where we define preference with the kind of key and use a default value for each. Now let us define a similar class called settings, which takes in the context. And since data store works asynchronously, we cannot call its functions on the main thread. So we're going to implement two generic suspense functions called get and set to read and save the values for the specific keys. We're going to create a suspend function with the generic type t called get, where we pass in a preference. And we're going to use the context to get the data store. And since its data will be a flow and we only want to read its data once, we're going to call the first function. This first function will read the first emission of this flow and return whatever values that this data provides us. Now from this data, we can read the preference.key, and if it exists, it will return this value. Otherwise, it will give us the default value that we stored for each of the setting. Data store will not have any data by default, and we need to return some default values at least. Similar to this get function, we're going to define a suspend function with a generic type t called setPreference. And with that, we are going to pass in the preference we are going to save and a value for it. This preference should be one of these values, and we're going to edit the data store. It requires to import the edit function from the data store library. We're going to call this edit function with whatever settings we have in this preference data store. We're going to put a value for the certain specific key that we have. This should be it for the settings class, but one update that I just realized to do for this specific application is that I cannot refactor to using a suspend function right now because there are a lot of places where this settings class is being used, and some of them are required to instantiate view models. So for now, I'll go with the regular function. And since it will complain that this piece of code requires a suspend function, we're just going to use run blocking to run this piece of code in the main thread itself. For now, I guess this settings class should be good to go. Now let me just fast forward the video to replace every place where this old settings class is being used. The beauty of using such an implementation is that at some places we don't even need to define the kind of generic class we want to use. For example, if I just use the new preference class, it automatically infers the type, so we can just get rid of the type definition. Now for the places where we want to call set, we will need to use coroutine scope. And for activities, we can just call the lifecycle scope dot launch and use the set function from there. Once we are done, we can just delete this old settings class. That's it for the video, guys. I hope you enjoyed it and got learned something new. Please don't forget to leave your thoughts in the comment section below. Thank you.